In this question, they're asking us to find the partial derivatives of a function z with respect to x and with respect to y, and the function z is given as y squared ln y plus x cubed y e to the x. So when calculating partial derivatives, the idea is take the variable that you're taking the derivative with respect to, so for example di z by di x, we're taking the derivative with respect to x, and set all of the other variables in the function to a constant, or just assume that they're a constant. So in this case, we would assume that all of the y's are just some constant numbers. And conversely, when we're taking the derivative of z with respect to y, we assume that all of the x's in the function are just numbers, and we just treat it accordingly. So let's just go ahead and do this. So let's take the derivative of z with respect to x. So if we look at the first term here, if we're taking the derivative of z with respect to x, we assume that all of the y's are just numbers, like 5. In this case, the first term is just a whole bunch of constants, like 5 squared ln 5. That's just one big number, it's just a constant. So the derivative of a constant with respect to x in this case would be 0, because the first term is just one big constant number. In the second one, we have something that looks like a constant y, so that could be 4 or 5 or whatever number you want, times the function x cubed e to the x. So because we have x cubed e to the x, we have a function of x times a function of x. We would like to use the product rule here. So essentially what we're going to get is, let's take the derivative of, so it's going to be y, because that's just a constant sticking out front of everything. Take the derivative of the first function and leave the second function alone. So we get 3x squared e to the x. Plus, and then we reverse the order, so now we leave the first term alone and take the derivative of the second, x cubed e to the x. And of course I could simplify this a little bit, and what I end up with is, say something that looks like, how about 3x squared y e to the x plus x cubed y e to the x. Now let's take the derivative of z with respect to y. So now, because I'm taking the derivative with respect to y, I assume all of the x's in the functions are just numbers, like 10 or 4 or whatever number I would like. And then I just take the normal derivative with respect to y. So the derivative of the first term with respect to y, we see here we have a function of y times a function of y. We have y squared times ln y, so we're going to need to use the product rule. So the derivative of the first function is 2y, and we leave the second function alone, plus the derivative of the second function and leave the first function alone. So y squared times 1 over y. So that's just the product rule for the first term. Now let's take the derivative of the second term. The second term involves the function y multiplying a whole bunch of stuff with x's in it. Now the stuff with x's in it, because we're taking the derivative with respect to y, we assume that the x's are just numbers. They're 15 or 26 or whatever number we would like. So essentially what this actually looks like is one giant number times y. So the derivative of some number times y, or some constant times y, is just that constant again. So we end up with x cubed e to the x as our derivative. And if I simplify this a little bit, I get 2y ln y plus y squared over y is just y plus x cubed e to the x. And that's it.